Today we're going to be looking at section 1.5, which is on using problem-solving strategies and models. And that's what our goal is for this section. Our goal is to solve problems using verbal model. And a verbal model is just a word equation that represents a real-life problem. So we're going to take our word problems and we're going to convert them into either a formula or a type of an equation that we're going to solve. So if we look at example 1, the driving distance between Boston, Massachusetts and Cleveland, Ohio is about 660 miles. So there's one piece of information that we're going to need, 660 miles. If you drive the trip in a total of 12.5 hours, what is your average speed? So those are the three things we have: distance, a speed, and we're looking for and a time. So we know that we're going to use the equation D equals RT. And we're solving for the average speed, so we're going to solve for R, which means R is going to equal D divided by T. And now we just have to plug our numbers in. Well, it's 660 miles, takes us 12.5 hours. 660 divided by 12.5 is 52.5. So that means our average speed is 52.5, and then we were in miles per hour. All right, so at this time, I want you to try guided practice question number 1. You can pause the video and hit play when you're ready to move on. And here's the answer to guided practice question number 1. So the flight will take about 12.5 hours. We're solving for the time in this case, so we got the t by itself, and then we plugged our numbers in. Now example 2 is to look for a pattern. And it says the table shows the number of seats in the first 4 rows of an auditorium. The remaining 10 rows follow the same pattern. We want to find the number of seats in the last row of the auditorium. Now, some of you are going to look at this problem one way, and some of you are going to look at it another way. There are many of you who say, okay, I'm just going to continue this pattern, and I'm going to figure out what is in the last row. And there are some of you that look at this and say, okay, I'm going to write an equation for it. Well, let's look at it both ways. So if we do this, continue the pattern, we're going to go 5, 6, 7, 8, 9. We want 10 more rows. So we're going to go 10, 11, 12, 13, 14. So we're really looking for the 14th row. And so we see that the pattern, we're adding 2 to each one. So this is going to be 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. And so when we look at this, we can see that there are 38 seats in the last row. Others of you are going to, so if we continue the pattern, that's how we would do that. Some of you are saying, oh, I can write this in an equation. Well, and we know that we're using y equals mx plus b. Well, the intercept is 0. And if we would go backwards, it would be 10. So the slope here represents how many it increases by. The b is our starting value. And so our equation would be y equals 2x plus 10. And then you can check with any row how many seats there are. So if we put in row 3, so if we put a 3 here, that's 6. 6 plus 10 is 16, and it works. But we're really looking for row 14, so if we put 14 in there, well, 14 times 2 is 28. 28 plus 10 is 38, and that also gets us to there. So either way you do it, whether you continue the pattern, whether you write the equation, it's perfectly fine. So we just want to know how many seats are in the last row. So there are 38 seats in the last row. Then we'll move down to example 3. And example 3 is drawing a diagram. All right, so it says you're hanging 3 pictures on a wall in your home, 16 feet wide. So what we're going to start doing is just drawing this picture. Here's the wall of your bedroom. Okay, we got 3 pictures. We know that the room is 16 feet wide. 3 pictures are 2 feet, 3 feet, and 4 feet. You want the space between the pictures to be the same, and for the space to the left and the right of the group of pictures to be 6 inches less than the space between the adjacent pictures. Now, the tricky part to this is you have to make sure that you realize that this one is in inches and these are in feet. So you can't put, it says the right of the group should be 6 inches more than the space, so this cannot be x plus 6 because this is in feet and this is in inches. So we can't have that there. We have to calculate that into feet. So how much is 6 inches in terms of feet? Well, it's 1/2 of a foot. So this is really going to be x plus 1/2, and this is going to be x plus 1/2. And they want to know how would we position those pictures. So here's our problem. Well, we know that all of these added up, the x plus 1/2, the 2, the x, the 3, the x, the 4, and the x plus 1/2 have to equal 16. So that's going to be our equation. X plus 1/2 plus 2 plus x plus 3 plus x plus 4 plus x plus 1/2 has to equal 16 feet. So there's our equation. Now we simplify it. So we have 1, 2, 3, 4x. We have 2, 5, 9, 10. If we add all of our numbers up to get our like terms. And so we have 4x equals 6, and x equals 6/4, which is 3/2, which is 1.5. So we've solved it. And always in a word problem, you have to make sure to answer it in a complete sentence, because x equals 1.5 doesn't really tell me what I want to know. They want to know, how should we position the pictures? Well, what is the distance between those pictures? Between the 2-foot and 3-foot picture and the 3-foot and 4-foot picture? That's 1.5 feet. Okay, so that's 1.5 feet. How much is on the outsides between the last picture and the wall? Well, that's x, which is 1.5 plus 1/2, so that's going to be 2 feet. So we need to write that out. So we're going to say the outside pictures should be 2 feet from the walls. And the distance between the pictures will be 1.5 feet. Now you could write that in inches if you would rather do it inches and calculate them all and say, well, it's going to be 24 inches from the wall and it's going to be 18 inches between the pictures. But however you would like to do that is fine. All right, example 4, standardized test practice. It says your long distance telephone plan charges 8 cents per minute for weekday daytime calls. We're going to call those D. And 5 cents a minute for nighttime and weekend calls. And we're going to just call those night. if you made a total of 220 minutes of long distance calls during a billing cycle, and your bill was $13.16, not including tax and fees, how many minutes of the night and weekend days or night and weekend calls did you make? All right, so our goal here is to write an equation. So we need to figure out what piece of information do we need to use to write the equation for this problem. So we're going to start with the 8 cents a day for the daytime calls. Plus it's going to cost us 5 cents for the nighttime calls. And we know that that's going to equal our total, which is $13.16. Well, the problem is I don't know either one of those. I do know that we made a total of 220 minutes of calls. So I want them to be the same variable. So instead of n, once again, just like we did in the other section, I know that my total is 220, and I'm going to subtract d. That's going to give me my nighttime calls. So what we're going to do now is we're going to solve this equation for d. So we're going to have 0.08d plus 0.05 times 220 is 11 minus 0.05d equals 1316. All right, we put our like terms together. Here we're going to get 0.03d. We subtract 11 over to the other side, and we're going to get 2.16. So then we have to take 2.16 divided by 0.03, and we're going to get 72. So D equals 72. So we look at our choices down there, and again, remember to read the question. Says, not including taxes and fees, how many minutes of the night and weekend calls did you make? Well, we have D equals 72. So is our answer A? And the answer to that question is no, it is not. Because we have to remember, what does D equal? D represents our weekday calls. Okay, they are asking here for the night and weekend calls. So we solve for D, which is the daytime calls, and we have to figure out what is the night and weekend. Well, we know that there's a total of 220, and we know that we made 72 minutes in daytime calls. So when we do the math on that, that gives us 148. So that is the answer, 148 minutes for our night and weekend calls. You have to make sure that when you are doing word problems, that you are answering the question that they asked. I guarantee you're going to have problems like that on your quiz and on your test, that people are going to try to trick you on your MCAs and stuff like that, that you need to make sure you're answering the question that's asked in the problem. So in this case, it's 148 minutes for the night and weekend calls. All right, I want you to take a couple of minutes to go to the guided practice questions. They are on page 36. I want you to take a couple minutes to do that. You can pause the video and then hit play when you're ready to check your answers. And here are the answers to your guided practice questions. Now notice in number 2, I decided to go with the route of making an equation. Our starting height was 2,400 at time 0, and we went down 210 feet, so I have a negative 210 as my slope, and then I put my 8 in. In number 3, we changed that equation from example 3 in your book. And so the distance between the walls in the banner is 9.5 feet, and then also the distance between each banner is 9.5 feet. And then in question 4, with the miles per gallon, I put H as our highway gallons, our highway gallons, and so then 28 minus the H, because we had 28 total gallons, is our city gallons. So I got H equals 23, which was my highway gallon, so then I had to subtract that from our original. So sometimes they'll give us that one where we will solve for C right away, and we could have done that. If we'd have put C for the 12 times C, and we'd had then 16, we could have had the 28 minus C, then we would have solved for C right away, and we wouldn't have had to make sure to check that one. So once again, section 1.5 is on using problem-solving strategies and models. There are many different ways that you can solve these problems. I recommend if it gives you a visual picture, draw the picture. A lot of times it will help you see what's going on there. There's some methods of looking for a pattern or writing equations. Whatever it happens to be, make sure that you are solving the question that they ask. Double check to make sure that your answer makes sense when you are done. So your homework assignment is on the bottom there. Make sure to go ahead and be working on those.